Hello and welcome. We're always told to look at the average to understand something. But what if that one single number is actually hiding the most interesting part of the story? Well, today we're going to peek behind the curtain, go beyond the average, and really discover the true character of our data. Let's get started. So here's our game plan. First, we'll see exactly why the average isn't enough. Then, we'll talk about how to measure the spread. After that, we'll get to the really cool part, the unifying idea of moments. From there, we'll explore the actual shape of the data, and finally, we'll wrap it all up by seeing why this stuff actually matters in the real world.
All right, let's jump right in. First up, we need to talk about the limits of that one statistic we all know and love, the average.
I want you to really think about this for a second. The next time you see a news headline that says the average salary is, or the average temperature was, do you feel like you really know what's going on? Because the truth is, you probably don't. And I'm about to show you exactly why.
Okay, take a look at this. This slide just says it all, doesn't it? We've got two different sets of numbers, dataset A and dataset B. And here's the kicker. They both have the exact same average of 10. But just look at them. Dataset A is perfectly consistent. It's just 10, 10, and 10. Dataset B, on the other hand, is all over the place. If we only looked at that average, we'd think these two datasets were telling the same story, but they're not even close. We definitely need more to the story.
And that leads us perfectly to our next big idea. If the average tells us where the center of our data is, we need another tool, something to tell us how spread out everything is. And that's where a little something called variance comes into play. Okay, so the official term is variance. And I know, formulas can look a bit scary, but the idea behind it is actually really simple. You just take each data point and see how far it is from the average. Then you square that distance, which does a couple of important things. It makes every number positive, and it gives a lot more weight to the outliers, the ones that are really far away. Finally, you just find the average of all those squared distances. That's it. So yeah, let's forget the math for a second and just think about the question it's trying to answer. Variance basically just asks, are all our numbers huddled up tight around the center, or are they scattered all over the place, far and wide? It's a single number that tells you how messy or how neat your data is. And this makes it super clear, right? A small variance, like our dataset A, means all the data is clustered together. It's consistent, it's predictable. A large variance, like our dataset B, means the data is all spread out. It's way more unpredictable. Just by adding this one extra number, our understanding has gotten so much deeper. So, we have the mean for the center and variance for the spread. But here's the beautiful part. These aren't just two random separate tools. Oh no. They're actually part of a single, incredibly elegant system. This is where it all connects. The course material we're pulling from for this explainer puts it just perfectly. Moments are measures that describe the characteristics, you could almost say the personality of a distribution. This is the key idea that ties it all together. And here it is. This is the big reveal. The mean isn't just the average, it's the first moment. Think of it as the data's center of gravity. And variance isn't just the spread, it's the second moment. It tells us how the data is distributed around that center. They belong together. This table lays it all out for us. We've already met the first two. The first moment is the mean, that's our center. The second moment is variance, that's our spread. But wait, there's more. The third moment, called skewness, tells us if our data is symmetrical or lopsided. And the fourth moment, kurtosis, tells us about the peakedness and warns us about extreme outliers. These four together, they give us a complete profile of our data. Now that we have this amazing framework, let's dig into those two higher moments. What can skewness and kurtosis really tell us about the shape of our data? So skewness, the third moment, is all about symmetry. Is your data a perfect mirror image on both sides, or does it have a long tail stretching out one way or the other? Then you've got kurtosis, the fourth moment. That's all about the extremes. Does your data have a really sharp peak and what we call heavy tails? That's a huge clue that you might have a lot of outliers. Reading skewness is pretty simple. If the value is positive, it means the tail's being pulled out to the right. A great example is income data, where a few super high earners stretch that tail. If it's negative, the tail goes to the left, and if it's zero, you've got a perfectly symmetrical shape, like that classic bell curve. And now for kurtosis. A positive value means a sharper peak, and this is the important part, fatter tails. Those fat tails are like a big warning sign. They're telling you that extreme events, those big outliers, are way more likely than you might think. A negative value means a flatter shape with thinner tails and fewer surprises. In finance, they sometimes call kurtosis the risk meter for a reason. Okay, let's pull it all back together. We've talked about mean, variance, skewness, and kurtosis. But the real power comes when you put them all together to see the complete picture.
Honestly, this is the best way to think about it. If you only have the average, it's like knowing just one fact about a person, like their height. But when you have all four moments, you have their full personality profile. You know where they stand, how volatile they are, if they lean one way or the other, and their potential for big surprises. And that potential for surprise is everything.
So from now on, you can look at any data set and ask these 4 simple questions. 1, where's the center? That's your mean. 2, how spread out is it? That's your variance. 3, is it lopsided? Hello, skewness. And 4, what's the risk of a wild, unexpected event? That's kurtosis. It's the whole shebang.
And that really brings us to the final, most important question. After everything we've talked about today, the average just isn't going to cut it anymore, is it? You now have the tools to ask smarter questions, to dig deeper, and to see the real story the data's trying to tell you. So, what else are you going to ask for?